Right. Got Trig lecture 329, 330, and 331. That's for 3 days, so we'll just be doing the same types of problems for 3 days. And on the 1st of April, we'll have a test, and then that'll be Thursday. And then on Friday, that'll be Good Friday. So here we go. The student will solve short problems involving distance, rate of speed, and time. This is just the type of thinking that we'll be using when we move into vectors. We're not going to be dealing with vectors, but it's just to get our brains warmed up for that kind of thinking. So here we go. Let's take a look at what we're dealing with here. Distance equals rate times time. It's a little formula we're going to be using. Distance equals rate times time. Rate is the rate of speed. Time is in hours or whatever it's measured in. When we pay attention to our units of measure, let's just jump in there and see what we got going on here. It says Ted left home and traveled toward the dump at an average speed of 60 miles an hour. So we don't know which direction he went. I'm just going to say he started here. Let's say the dump is that direction, and he's going 60 miles an hour. Now this is nothing more than an indication of direction. That direction, 60 miles an hour. And it says Aaliyah left at the same time. That's important. And traveled in the opposite direction. So she went this direction at an average speed of 70 miles an hour. How long had Aaliyah traveled when the distance between them was 130 miles an hour? Well, when that distance reaches 130 miles an hour, they'll both have traveled the same amount of time because they left at the same time. So what we got to figure out is how fast are they moving apart from each other? What is the rate at which they're moving apart from each other? And I'm going to use this formula right here. Distance is equal to rate times time. And I think you can see that if he's going 60 miles an hour this way and she's going 70 miles an hour this way, the rate at which they're moving away from each other is 130 miles an hour. So our distance is going to be 130 miles an hour. I'm sorry, 130 miles is equal to, let me scroll this a little bit. Our distance, which is 130 miles, is equal to the rate. Well, they're moving away from each other at 130 miles an hour, oops, times the time. I think you guys have this figured out already, I'm sure. How do I solve this? I divide both sides by 130, and I get 1 is equal to t. And then I ask myself, what unit of measure are we using for t? And it says it a couple of times, miles per hour, so time is in hours. And so that would be 1 hour, if I haven't made a mistake. Just use this formula, distance is equal to rate times time, and a little bit of logic. Does that make sense? Hope it does. Let's move on to the next one and have a look. Shauna made a trip to the train station and back. So she went a certain distance and then she went the same distance back. On the trip there, she drove 32 miles an hour. On the return trip, she went 48 miles an hour. How long did the trip there take if the return trip took 2 hours? Okay, so here's what we're dealing with. Here's Shauna. She's going to the train station. We'll call this T for train. And she was, on the trip there, she drove 32 miles an hour. Then she drove back. On the return trip, she drove 48 miles an hour. So here we are. She's at trip back. She's driving 48 miles an hour. The distance is the same. How long did the return trip take? How long did the trip there take? I'm sorry, how long did this trip take? This trip. If the return trip took 2 hours. So let's take a look at the return trip real quick. Distance equals rate times time. The return trip took 2 hours. The rate was 48 miles an hour. Oops. Okay, I'm going to scroll a little bit so you make sure you guys can see this. I'm saying the return trip is what they give us some information about. It took 2 hours, and she was going 48 miles an hour. So that distance is, what is that, 96? So if the distance back is 96, the distance there is 96. And the question is, how long did the trip there, this one, take if the return trip took 2 hours? So we figured out the distance using that information, and now we know that if the distance is 96, and the rate there, what did we say it was, 32 miles an hour? How long would that take? And we just divide both sides by 32, and that's 3 exactly, isn't it? So T is 3 hours. Traveling at 32 miles an hour, it took her 3 hours to get there, and traveling 48 miles an hour, it took her 2 hours to get back. That's using distance equals rate times time, and a little bit of logic. There we go. And let's see if I got that right. I need to be checking my answers if I can find my key. Hey, here's my key. First one I got 1 hour. Yay. The second one I got 3 hours. Yay, I'm gonna roll. Let's take a look at the last one. Matt left the store and traveled west at an average speed of 65 kilometers an hour. Sometime later, so the times aren't going to be the same, sometime later Elisa left traveling in the same direction, but at an average speed of 78 miles an hour. So she's traveling faster than him. She's going to be catching up to him. After traveling for 5 hours, Elisa caught up with Matt. How long did Matt travel before Elisa caught him? Okay, well, let's take a look at this. Matt left the store and traveled west. At 65 miles an hour, or kilometers per hour. Yes. Sometime later, Elisa left traveling in the same direction at 78 miles an hour. So she's going 78 miles an hour. These just, or not miles an hour, kilometers per hour. And these little arrows are just indicating direction only. They're not vectors, for those of you who know what vectors are. And after traveling 5 hours, she catches him. So this is Matt, and that's Elisa. I think that's what I said her name was, yeah. After traveling 5 hours, Elisa caught up with Matt. Well, let's see how far she went. Talking about Elisa here, we'll say Elisa's distance, call it D sub E for Elisa, is equal to rate times time. She's going to travel so far at a rate of 78 kilometers per hour. For how long did it say? After traveling for 5 hours, she catches him. Now, by the time she catches him, he got a head start. She's traveling faster. When she catches him, the distances that they've traveled will be exactly the same, because he's taken off and she catches him, and the distance that she traveled will be the same as the distance that he traveled. Something to bear in mind. So distance equals whatever 78 times 5 is. I'm not going to trust my brain on that one. Whoops. Help if I did the right buttons. 390. So she travels 390 kilometers and catches him. Now, what are we asked for? That means that Matt, I think that's his name, Yeah, Matt also traveled 390 miles an hour, because at that the point when she catches him, they both traveled the same distance. So we're over here talking about Matt now. He gets caught at 390 kilometers. His rate was given at 65 kilometers per hour. And I think we're going to be asked, how long did he travel? Yeah, what's the time that he traveled? So I'll just divide this distance equals rate times time equation by 65 and isolate my time. So here we go, 390 divided by 65. 6 hours, if I haven't made a mistake. The key to this one was recognizing that if she's following him, he takes off earlier and she's following him going faster. When she reaches him, when she catches him, they've traveled the same distance. And so if she traveled 390 miles or kilometers, then so did he. And it was easy then to figure out how long he took. That's the type of thinking we're going to be doing. Distance is equal to rate times time, and a little bit of logic, and you can work these problems out. If you can't, join me on Zoom, or if you're coming to class, ask me questions in class. You can do this.